Life cycle assessments, which I'll refer to as LCAs, are a popular method used to measure a product's environmental impact. LCAs measure the emissions associated during every phase of a product's life. It starts first with the emissions used to mine raw resources. It then measures emissions to manufacture the product along with the transport of raw materials in and the export of products out. Life cycle assessments can be used to measure the emissions of individual basic products like one brick, or can sum many components together to study the life cycle of, say, a single-family home. For the construction of a home, the emissions generated during construction are added, followed by the emissions during the structure's use. This is typically a function of the electrical and heating of the home over the course of its life, say 75 years. The final phase is the demolition. These emissions can be viewed linearly with time and are often described as cradle-to-grave studies, measuring the total impact a product will have on the environment over its life. The phases are often divided into two separate categories: embodied emissions and operating emissions. Operating emissions are easily measurable and are often the only emissions reported in climate action plans. Cities ask utilities how much electricity or natural gas is used within the city and apply emissions to those values, allowing for a measurable way to track progress. The other phases, often described as the embodied emissions, are more difficult to measure. Despite omitting embodied emissions, climate action plans are dealing with the bulk of the issue. Detailed life cycle assessments show that roughly 90 to 95% of typical U.S. buildings' life emissions occur during the operating phase. Here, embodied emissions are shown in red, while operating phase emissions are shown in blue. This study of a standard U.S. single-family home calculated that over 93% of emissions occurred during the use phase. This is likely to change in the future, though. For a standard energy-efficient building, the embodied emissions increase to 15 to 20% because they are a greater share of a smaller number. Life cycle assessments are typically performed one of two ways. First is the economic input-output method, called EIO. The EIO measures the emissions of a product by applying an emission-to-dollar ratio for different processes. Simply, the user provides a dollar figure for a process, and the EIO method applies a ratio unique to that sector that converts the economic value into greenhouse gases. Carnegie Mellon University has a free online resource that has taken national economic data broken into 400 sectors and then paired those sectors with emissions that they're responsible for. The upside of the EIO methodology is that only a dollar figure and a sector are needed to know how many emissions were produced by that process. The other LCA process is the original. Rather than a ratio that converts dollars to emissions, the process-based method converts the number of units into emissions. The process-based method relies on databases of resources that calculate the emissions of specific units and processes. The difficulty with this methodology is that there simply is not an inventory of all products and resources from which to draw. In order to use the process-based method, I needed to know how many tons of CO2 were emitted during the embodied phase of buildings. I compiled 70-plus reports completed by 42 separate authors, aggregated by 4 larger studies, creating a database that was incomplete across all attributes but one: the embodied emissions per meter squared of building. The distribution of the data suggests that the embodied emissions of 1 meter squared in residential homes is 409 kilograms of CO2 equivalent. This excludes extreme outliers. For commercial buildings, it's much greater at 777 kilograms CO2 equivalent per meter squared. I then used census data to determine the average square feet for different types of residential structures. For single-family homes, that value is 166 meters squared. Multiplying the two values gives me the GHG emissions associated with the embodied emissions of a single-family home. Using the Carnegie Mellon EIO calculator and my process-based database, both the economic input-output LCA and process-based LCA can be applied to past disasters.